Good evening, everyone. Welcome to this wonderful Cisco U Theater. Before we dive in, I'll quickly introduce myself. My name is Mohit. I work as a technical content developer here in Cisco's Learning and Certification. I'm a Cisco certified DevNet professional with 5 years of experience with various DevOps tools like Ansible, Terraform, and my personal favorite, Kubernetes, something I'm really excited to talk about today. How many of you have worked with Kubernetes before? Okay, that's a great number. And how many of you have deployed an application in Kubernetes, like a microservices architecture in Kubernetes? Perfect. Now, I know Kubernetes can feel a little overwhelming initially with so many components working together in different ways. But don't worry, I'm here to make the learning fun with examples and demos. We will learn Kubernetes by deploying a web application and discussing why we are doing what we are doing. So we'll be deploying a simple e-commerce application, a pretty classic example. And the architecture of the application is something like this. So we got a front end running. That is the Nginx server that would be taking in all the requests from the internet. And we have a Python backend, let's say a Python Flask application that would be taking in all the API requests and responding to them. We have a MySQL relational database that would be used to store all the user data. So normally, all the web application always follow this kind of architecture. They have a front end that is exposed to the users on the internet. We have a backend which take care of the API request and responses part. Then we have a database to store the user data. So we'll be deploying this application in a Kubernetes cluster. Before we start, there is a WebEx space created for this session. So if you have any question, please feel free to send your questions on the space. I'll be moderating the space till 28th of February. And after the session, I'll be there in the walk-in lab area, hall 3. So if you want to discuss something or clarify something, please feel free to drop by. I'll be happy to have a chat. Now, with the rise of containerization and microservices architecture, each application is deployed as a microservice. And each microservice has hundreds or even thousands of instances running. With so many instances running, there are challenges. One, how are you going to deploy these many instances? Two, how are you going to scale them? How will you upscale or downscale your instances depending on the incoming traffic? Three, what if some of your containers crash? How will you ensure your application is always up and running, always available to the users on internet? To tackle these challenges, we need a container orchestration solution. And Kubernetes is one such popular container orchestrator. It helps you deploy, it helps you scale, and manage your containerized application. But you all might be wondering, what exactly is Kubernetes managing? And this brings us to the fundamental unit of Kubernetes, pods. A pod in Kubernetes is the smallest deployable unit. It contains your containers that share the same network and storage environment. Assuming you have the Kubernetes installed, you have all the components up and running, you're all good. Now, to deploy a pod, you can go to your terminal. You can use kubectl. Kubectl is the command line interface for Kubernetes. You can run the command kubectl run. Let's say you're deploying the front-end pod. You can use the command kubectl run, the pod name, and it's an Nginx container. So you'll use the Nginx image and expose your front end on port 80. Now, there are some problems with the CLI approach. One, it doesn't support all the Kubernetes configuration. And this is not reusable. This is not portable. You cannot give it to your operations team and ask them to run the CLI command and to deploy all your resources. And with very complex deployments, this command can get super long, making it very tough to understand and prone to errors. So a more efficient way, a more better way would be to use YAML files. So most of the deployments in Kubernetes is done using YAML files. And almost all the resources follow a similar structure of your YAML file. One, you have the API version, where you are going to specify the version of your API. Then you will write the kind field, where you are going to tell what type of resource you are going to deploy. Then you have a metadata block, where you are going to provide the details about your deployment. It can be the name of your deployment. It can be the labels. Labels are key value pair. They are optional, but they are always recommended. Labels help you with organizing your resources, and they also help you with selection. Selection is something we are going to discuss a little later, but right now you can think labels can help you with organizing your data, organizing your resources. So always a good practice to give meaningful names to your labels. Then you have the spec section. That is the heart of your YAML file, where you are going to specify all the details of your deployment. So for the front-end pod deployment, rather than using the CLI command, a good way would be to write a YAML file, and the YAML file would look something like this. You have the API version. It's going to be v1, and different resources behaves differently with different API versions. So always a good practice to refer the official documentation and select the API version accordingly. We have the kind field, so we are deploying a pod, so we'll write down pod. Coming down to the metadata block, the name of your pod is going to be front-end pod, and you can give it some meaningful labels like app e-commerce front-end. Going down to the spec section, here you have a containers block that would contain a list of containers. We are going to deploy a single container, that is the front-end container. You specify the image and expose your front-end on port 80. Now, before I deploy this, there is a very popular misconception that a pod can run only a single container, and that is not true. A pod, if you see, it's a list of containers, and it can contain multiple containers. But it is not a good practice to have multiple containers inside a pod. That's because, let's say, we have our front-end container and the back-end container inside a pod. And assuming something goes wrong with the front-end container, the pod would restart. And that would result in your back-end container to also restart. And so that is not something that you would wish to have. So we need to separate them. We need to isolate them from each other. I mean, that's the principle behind microservices architecture. To deploy the resource, you can go to a terminal. You can use the command kubectl apply -f for file, and specify your pod YAML file. Kubernetes will go ahead and deploy your pod. To see all the pods, you can use the kubectl get command. You can write kubectl get pods. It will list you all the pods that are running in that particular cluster. Now, if you want to see a lot more details about your pod, you can use kubectl describe. That can list you all the other details about that particular pod. Then, as I said, you can use label to filter your pods. You can use the command kubectl get pods -l for labels, and you can write down the label key value pair. It will list you all the pods that contain that particular label. To delete a pod, you can use the command kubectl delete pod and the pod name. So similarly, you can deploy your Python backend application as well. Similar stuff, API version, kind, metadata. And here the container is going to be the backend container with the, let's say you have version 1.0 right now. So you can use my backend app 1.0 and expose your Flask application on port 5000. To deploy this pod, you can use the command kubectl apply -f and the file name. Now moving on to the database file, this is little different. Here we have a couple of changes. To run a MySQL database, you need to pass some configuration parameters. Parameters like database name and your database password. We are going to pass these configuration parameters using environment variables. You can write your MySQL database key and provide the value as e-commerce. But if you see, the value of the name of your database is written in plain text. And we cannot use the same for our password. Writing down your passwords in the YAML file is a huge security risk. Anybody who has access to the YAML file can see your database password. So a good way to tackle this would be to use secrets. Secrets contain your passwords in a base 64 encoded string. And you can write down the key of your password, and the value from it is fetching your password is a secret. And it's a base 64 encoded string, and encoding is not a very secure way to write down your passwords. It's very easy to decode it. So to enhance your security, you can encrypt your etcd data store, where Kubernetes usually store all the resources and all the configurations. So a good way to always also impose role-based access controls to limit people accessing all your secrets and all the other resources. And the second change we have made is in the volume mounts. So by default, Kubernetes is going to store all the data inside your container. So if a container crash or if a container restarts, you would lose all the data. Because right now the data is stored in a container. But that is something you don't prefer for your containers where you're storing the user data. So a good way to tackle this would be to use persistent volumes, volumes that exist independent of the life cycle of your container. It can be your network file system, or it can be a storage provided by your public cloud, Amazon S3 bucket, or it can be your private data center. To specify that volume, you can use persistent volume claim, in which you are going to request the minimum amount of storage you would require to run this particular pod. Let's say you need 5 gigabytes to run this pod. You can specify that in the persistent volume claim. And while deploying it, Kubernetes will scan all the persistent volume and find you the volume that has minimum 5 gigabytes. So to deploy this, you can use kubectl apply-f and the YAML file name. So right now, our current deployment looks something like this. We have a single instance of our Nginx server exposed on port 80. We have a single instance of our MySQL database on port 3306, and a single instance of your backend application. They are all part of a single cluster. So that means they are all part of the same network. That means you can access any pod from any of the pods. Let's say you want to try to go inside a front-end pod and check if you are able to reach the backend pod. You can use kubectl get pods -o wide. It will suggest you all the IP addresses of that particular pod. The IP address of the front-end pod is 1024.02, and the IP address of backend pod is 1024.03. You can use the exec command, kubectl exec -it, and access the terminal of your front-end pod. That will take you into the front-end container that is running. And to check the reachability, you can use ping and ping the IP address of your backend pod. Now, one thing in Kubernetes is your containers have a very short lifespan. They would keep crashing. They would spin up with the different IP addresses. So it's not good to rely on IP addresses. But rather than that, we can use the pod name. So even if your containers come up with a different IP, they would always come up with the same name. And Kubernetes will automatically resolve the name and fetch you the present IP, and you will be able to reach the backend pod. So it's not a good practice to rely on the IP addresses. It's good to use the pod name instead. So right now, we have only a single instance of our front end, a single instance of our backend, and a single instance of our database. But is a single instance really enough to handle the traffic? Will it be able to handle all the traffic that is coming from the internet, just like one container running for each component? No, right? So we need to manage our Kubernetes application at scale. And there is one more limitation. If your pod fails or if your pod is removed, it will not restart automatically unless there is something that is managing it. And that something in Kubernetes is called as deployments. Deployments uses a declarative approach in which you are going to specify what is the desired state of your deployment, and Kubernetes will work internally to keep that same state. So let's say if you are deploying 3 instances in your deployment, if you manually remove one, Kubernetes will automatically spin up another one to maintain that number. To create a deployment, will again write some YAML files. In this, the API version is going to be app/v1. It is different from what we had for pods. The kind would be a deployment. It's not a pod. And in the metadata block, we are going to specify the name and the labels. Now, coming down to the spec section, you have a field called replicas. In replica, you are going to write down the number of instances you would like to have for the particular pod. We are going to write down 3, so there would be 3 instances of the front-end pod running. In the selectors block, we are going to define the selection criteria. And here we are using our labels. As I said, labels can also help you with organization, but they can also help you with selection. So all the pods that would match with that particular label would fall under that deployment. And if you see the labels defined in the criteria and the labels of the front-end pods are matching. So in the template section, you are going to have the similar pod YAML file where you will write down the metadata, and you are going to write down the container definition. You'll use the Nginx image. You will expose your application on port 80. But here, there is a small change. We are not writing the name of the pods. Usually, whenever you'll deploy your pods using a deployment file, the name of the pods would be your deployment name and a unique identifier attached to a pod. And this is something we'll look into a little later. So Kubernetes, so if you deploy this file using the command kubectl apply-f and the file name, you will have 3 instances of the pod running. So there are some key advantages of using deployments. One, you can upscale or downscale your instances anytime. You can use the command kubectl scale deployment and deployment name and specify how many replicas of that particular pod you would like to have. So if you write down 5, Kubernetes will deploy additional 2 to maintain that number. And if you want to verify, you can go to kubectl get deployment and the deployment name. And you can see there are 5 instances running, with 5 of them are available. Now, it can also be used to update your application. Let's say your development team is coming up with a new version. They made the changes, they pushed the code on the GitHub repository, and now a new Docker image is available, and you want to update your application. You can use the command kubectl set image. You can specify the deployment name and for which container you would like to update the image. And you can give the new image name. And Kubernetes will deploy your application in such a way that there will not be any downtime. So let's say if you have five instances running, it's going to take 2 of them down. It will replace them with a newer one. Then it will take the rest of the 3 down. And it will replace them with a newer one. And this is called rolling strategy. This is different from a recreate strategy where it will take all of them down and replace them with a newer one. And that we are going to have a downtime. So by default, it is always rolling strategy unless you explicitly mention. And if you want to see the history of your rollout over the entire course of deployment, you can use the command kubectl rollout history and the deployment name. You can see the changes you have made and along with what all things have been changed in that particular revision number. Let's say something goes wrong with your particular deployment, you can roll back using the command kubectl rollout undo and the deployment name. It will take you 1 revision number back. But let's say if you want to go to a specific revision number, you can specify the to revision argument and give the revision number. And all this is done with no downtime. So our current deployment looks something like this. So right now you have 3 instances of your front end, 3 instances of your back end, and 3 instances of your database. And it is all self-healing. If you manually delete one pod, Kubernetes will automatically spin up another one to maintain that number. Now, as I said before, you cannot rely on your IP addresses because IP addresses keeps changing. So a good way to deal with that was to use pod names. But here, even the pod names are not reliable because pod names, I mentioned, we don't specify the pod name in our deployment. It will use a unique identifier for all the pods. So if a pod crashes, it will come up with a different name. To solve this, we need to bring all the pods under a single umbrella. And that single umbrella in Kubernetes is called services. So these are the three primary services provided by Kubernetes. Cluster IP. Cluster IP is always used for pods that want to communicate internally. You don't expose these instances outside the container, outside the cluster. Then you have a node port service in which you are going to expose a particular port of your node, and that can be used for internet access. And the third service is load balancer, in which you can integrate your public cloud load balancer for external access. So in the architecture, we only exposed our front end for the external access, but our backend and database always stay within a cluster and they are not exposed to the internet. So we are going to use load balancer service for the front end, but we are going to use cluster IP for our backend and our database because they are not exposed externally. To deploy a service, you are going to write a YAML file. Here, API version and the kind of the deployment is a service. In the metadata, like to specify which all pods fall under that particular service, again, it is done using labels. So if you see all the pods that would contain that label would fall under that particular service. And the labels are matching with our front-end pod. And in the spec section, you are going to define what type of service this is. This is a load balancer service. And selection is done using labels. Then you have a ports block where you're going to specify the port of your service and the target port. So if any request that would come on port 80 of this service would be redirected to port 80 of your pods. So port 80 is where the Nginx service is running for our pods. And services always help you with layer 4 routing, so the protocol can be TCP or UDP. Similarly, for our backend service, the type of service is going to be cluster IP. It's not load balancer because we are not exposing our backend component to the internet. It's going to be cluster IP. Selection is done using the labels of our backend pods. And the port of the service is 5000, and any service that would come on port 5000 would be redirected to the port 5000 of the pods. I mean, the port and the target port should not be same, but just to keep it consistent, it's a good practice to use the same port numbers so that it will be easy for us to debug in future if something goes wrong. And we can deploy these services using the command kubectl apply-f and the file name. So our current deployment looks something like this. You got a load balancer on the edge of your cluster. Any request that would come in would be load balanced between all your nodes. It can be round robin, or you can choose any algorithm you would like to use to balance your traffic. And any request that would come on port 80 of our front-end service would be redirected to port 80 of your pods. That is the Nginx server. And our front-end can communicate internally using cluster IP service. And again, we are going to use the service name rather than using the service IP, because services can also crash and they can come up with a different IP addresses. So we're going to use HTTP backend service and port 5000. So the request that would come on port 5000 of our backend application would be redirected to port 5000 of our backend pods. And they can also communicate internally within the database and the backend service. So this is a good deployment. I mean, it's not a very perfect deployment. Before I wrap up, I would like to conclude by saying there is a lot more things you can explore on your own in Kubernetes. I would highly recommend learning ingress controllers. Ingress always let you do layer 7 routing. The routing is done depending on the HTTP request that is coming. So it would do a regular expression matching with the HTTP request, and accordingly it will redirect your traffic. Say, in case of Amazon, if it is, say, Amazon Prime Video, Amazon Music, or Amazon Shopping Cart, depending on the HTTP URL, it will match your request and it will accordingly redirect it to the services. Now, if you want to learn more on Kubernetes, Kubernetes is part of our DevNet track, and you can always go to Cisco U to learn more about the DevNet automation and network programmability. We can also explore our Cisco U tutorials, Cisco U courses, and specialized custom learning tracks. So a great place to learn, to upskill, and certify yourself across various Cisco technologies. So yeah, that's all, guys. Thank you. And if you have any question, you can let me know. Thanks.